So there's a new kind of AI out there, and honestly, it's a total game changer. It's called Agentic AI. And no, these are not just the chatbots you're used to. We're talking about autonomous systems that have the power to actually act on our behalf. But, with that kind of incredible power comes a whole new world of risks, and that's exactly what we're going to break down today. And look, this isn't some science fiction far off in the future thing. Gartner is predicting that by 2028, which is just around the corner, a full one-third of all enterprise apps will be using agentic AI. Think about that. This technology is coming at us fast, which means we have to get serious about making it trustworthy, like right now. So, what exactly is agentic AI? Well, unlike a simple chatbot that kind of just sits there waiting for you to tell it what to do, these agents can actually sense what's going on, think through a problem, and then take action, all by themselves. I mean, we're talking about an AI that can schedule your meetings, trade stocks for you, or even buy things online, all without you having to click approve. They're not just following a script, they're interpreting data and making their own decisions. Now, that level of power is incredible, but it also opens up some massive new vulnerabilities. So let's start with the first huge challenge, the threat from the outside. What happens when these incredibly powerful tools get turned against the very people they're supposed to be helping? The first threat is hijacking. Just imagine this for a second. The AI agent you set up to manage your company's finances suddenly starts operating on behalf of, well, a criminal. An attacker figures out how to send it new commands, and just like that, your own tool is now their weapon. So how does that happen? Well, the main way is through something called prompt injection. And this isn't some minor issue. OWASP, which is a huge authority in cybersecurity, calls this the #1 attack vector. It's basically tricking the AI by sneaking in malicious commands that force it to do things it was never, ever supposed to do. Next up, you've got infection. We all know about viruses in our software, right? Well, AI models can be infected in a really similar way. And here's the scary part. Since most companies don't build their own AI models from scratch, they're downloading them from other places. If that model has malicious code hidden deep inside, you could be deploying a compromised system and not even know it. Now, one of the most dangerous threats is data poisoning. An AI is only as smart as the data it learns from. So if an attacker can subtly corrupt that data, the results can be absolutely devastating. The best analogy I've heard is it's like putting a tiny bit of toxin in the drinking water. You might not notice it at first, but it makes the entire system sick from the inside out. And of course, there are other clever attacks too. You've got evasion, which is where attackers mess with the inputs to confuse the AI and get it to make a mistake. And then there's the flip side, extraction. This is all about the output. It's where an attacker tricks the AI into leaking sensitive info, like your customer list or company secrets, bit by bit. And finally, there's the good old denial of service attack. Think of it like a highway at 5 p.m. during rush hour. There's just not enough road for all the cars. An attacker can totally flood an AI agent with so many requests that it just grinds to a halt, completely overwhelmed and useless for anyone who actually needs it. Okay, so we've covered the bad guys trying to break in from the outside. But what happens if the problem isn't a hacker? What if the chaos comes from the inside, from a system that just doesn't have the right rules and oversight? To see what I mean, let's walk through a little story. Imagine a recruiting firm. They decide to go all in on AI. They set up an agent and give it full autonomy to read resumes, schedule interviews, and even send out job offers. The goal? To be faster, more efficient. But things go wrong, and they go wrong fast. First, the AI sends out a formal job offer to a candidate without anyone signing off on it. This immediately brings up a huge governance problem. Where do you draw the line between autonomy and oversight? This is exactly why people talk about needing a human in the loop. You have to know when a person needs to step in. So the HR team asks a pretty simple question. Why did the AI pick this candidate? And you know what they get back? Crickets. Nobody has an answer. The AI's reasoning is buried inside a complex black box. And this really highlights the challenge of transparency. I mean, if you can't understand why an AI makes a decision, how on earth can you trust it? Then they dig a little deeper and find something even worse. Perfectly good candidates are getting rejected over and over. And the reason? The AI was trained on biased data that favored applicants from certain universities or with certain backgrounds. This is a massive governance failure. If you don't watch your training data, you risk building discrimination right into your systems. So, inevitably, the firm gets sued. Now, who's to blame? Is it the AI? The HR team, the company that sold them the model. This is the accountability crisis you run into when you let autonomous systems run wild without clear rules. Okay, we have definitely seen the risks, both from outside hackers and internal chaos. But it is not a hopeless situation. So let's shift gears from the problems to the solutions. How can we actually build the digital defenses we need to make agentic AI safe? On the security side, it's really a clear four-step process. First, you have to discover. You just can't secure what you can't see. That means finding every single instance of AI, especially the unauthorized shadow AI your teams might be using, because that's a huge backdoor for attackers. Second, you manage its posture. This is just about making sure every AI is following basic security rules, like having proper encryption and access controls. Third, you test it. You have to stress test these things to find vulnerabilities before they go live. And fourth, you protect it in real time with what you can think of as an AI firewall that's constantly watching what goes in and what comes out. That's your frontline defense. Then, on the governance side, there are three pillars. You have lifecycle governance, which makes sure these agents are properly approved and managed from start to finish, preventing that chaos we saw with the recruiter. Then there's risk and regulation, which is all about making sure you're complying with the law so you don't get sued. And finally, there's constant monitoring and evaluation. You have to keep checking to make sure the AI is still doing the right thing, which is how you catch problems like bias before they spiral out of control. Now, it's really tempting to look at security and governance like two separate checklists. You do one, then you do the other. But to really, truly build AI you can trust, you have to understand that they are two sides of the very same coin. This slide just nails it. Governance without security is fragile. You can have all the best rules for fairness and transparency in the world, but if a hacker can get in and poison your data, all those rules just collapse. But on the other hand, security without governance is blind. You can build an unbreakable digital fortress around your AI, but if the agent inside is biased or making decisions nobody understands, then all you've done is perfectly protect a broken system. And that right there is the core takeaway. Trust doesn't just happen by accident. It's what you get when you combine the technical defenses of security with the rules and ethical guardrails of governance. You absolutely have to have both. One without the other is a recipe for disaster. So, as we wrap up, the conclusion here is pretty clear. The rise of agentic AI isn't a question of if, it's a question of when. It's coming, and it's going to be part of the tools we all use every single day. So the only real question left for us to think about is this: when it gets here, will you be able to trust it?